In this video, we are going to look at simplifying algebraic expressions, otherwise known as collecting like terms. So what I'd like you to do is first think about when you make a grocery list. So let's say I want to make some smoothies. I'm making a strawberry kiwi smoothie and a very berry smoothie, and I've listed the ingredients of that smoothie below. And I want to write a grocery list so that when I get to the grocery store, I know exactly what I need. So what I'd like you to do is pause the video, make a grocery list for these two smoothies, and then start up the video again when you're ready. Okay, so chances are your grocery list looks something like this: 1 cup of raspberries, 1 cup of milk, 3 teaspoons of honey, 2 cups of strawberries, 1 cup of apple juice, 2 bananas, and a kiwi. Right? And I want to know, why did you write 2 bananas instead of writing a banana on your list twice? Right? Why did you write 3 teaspoons of honey instead of saying 2 teaspoons of honey and then 1 teaspoon of honey according to the recipes? Right? You combined them together. And that sounds kind of silly when we talk about grocery shopping. You're like, well, then I know when I'm grabbing a banana that I need 2 of them and I don't have to come back. But when we're doing algebra, for some reason, we don't necessarily think of it that way. We don't apply it the same way. But that's basically how it works when we are adding and subtracting terms that have the same base. So if I'm looking at these algebraic expressions and I want to simplify them, you can think of it like a grocery list in the sense that I want to write it in the least amount of terms as possible. So if I have 2a plus 3a minus 5a, how many a do I have all together? And the answer is 0, right? 2 plus 3 is 5, and then I'm minusing a 5, so I have 0. If I look at the second one, I have 2a plus 3b minus 4a plus 7b. And when we're looking at a grocery list, remember, we only combined the terms that were the same. So I didn't say, 2 bananas and 3 teaspoons of honey is, 5 banana honeys. That doesn't make sense. You only combine the ones that are the same. So if I'm looking at question 2 here, I see I have a 2a and a minus 4a. We always take the sign that's in front of our terms. And that together is giving me a minus 2a. Then I have a 3b plus a 7b. So all together, I have plus 10b. And I'm not going to combine my minus 2a and my 10b because they're different. One's an a, one's a b. I can't add them together. And so that's as simple as I can make that expression. So what I'd like you to do is try question 3 and 4. Can you simplify these? I'm remembering only to combine the bases that are the same, and this has to do with powers as well. So you can't combine a t and a t squared. We consider those different in terms of their bases when we're adding and subtracting. Okay, so try these, pause the video, and then start it up again when you are ready. Okay, so let's look at question number 3. My first is a 2ab, so I'm looking along my list to see if I have other ab's, and I do. I have a minus ab here. So I'm going to combine those together and have just one ab, and we don't need to write a 1 in front. We can assume that it's 1 ab. Then I have a 5a, so I'm looking for others that just are an a, and I have one here. And so all together I have a plus 6a. And then I have this minus 7b, and I'm looking for other ones that are just b. I have that here, minus 3b, so minus 7 minus 3 gets us to minus 10b. And my final answer there, I don't have any other like bases, the bases that are exactly the same, and so I'm going to leave that as my final answer. And for question number 4, I have a t, a 4t, and I have a minus 3t, so altogether I just have 1t. I then have a 6t squared and a minus 2t squared. So altogether I have a plus 4t squared. And then I have this plus 3t cubed. There's no other t cubes for me to combine that with. The other thing you might come across when it comes to simplifying is when you have a number outside of a set of brackets. And we're going to use something called the distributive property to solve this out. So when you have something outside of a bracket like this, that number outside of the bracket applies to every single term inside of the bracket. So in this first example, the 3 doesn't just apply to the 2x, it also applies to the 2y. And so what I'm going to do when I solve this out, if I write out what I'm doing, I'm going to do 3 times 2x plus 3 times 2y. So it applies to every term that's inside of the brackets. And so all together, I have 3 times 2x, which gives me 6x. And I have a 3 times 2y, which gives me 6y. And then I can look to see if I have any terms I can collect together. And in this case, I have an x and a y, so I can't combine those together. So I've simplified this as much as possible. Okay, so I want you to try these two, question 2 and question 3, remembering that the number outside of the brackets applies to everything inside of the brackets, and then be sure to combine if there's any that can be combined together. So pause the video and start it up again when you're ready. Okay, so for this first one, our 2 applies to the 3ab. It also applies to the 2b, and it's applied to my minus 4a as well. You'll notice that I've kept the signs with the terms. So my 2 is a positive 2, so it's positive 2 all the way. My 3ab is positive, my 2b is positive, but my 4a is negative. And so I've kept the terms with their sign as well. Right? And now we can solve this out. So 2 times 3ab is 6ab. 2 times 2b is 4b. And 2 times negative 4a is going to be a minus 8a. Then I'm looking and I'm not seeing any terms that can be combined together, so this is as simplified as I can make the expression. And question number 3 here, that minus 3 is going to apply to our 4a. It's also going to apply to our 7b squared. And it's going to apply to our minus 6ab. Again, you'll notice that I've kept the sign with its term. So now I have a negative 3 times 4a is minus 12a. Negative 3 times 7 is negative 21b squared. And then negative 3 times negative 6 is plus 18ab. Again, I'm not seeing any terms that can be combined here, so I'm done. Okay. So let's put that all together and look at simplifying some expressions that have a multiplication out front, where terms can be combined together, and put it all together to simplify this expression. So let's work on question 1 together. So the first thing I'm going to do is expand out my brackets using the distributive property. So I get 16 times 8, 16 times a minus x, and then I have a minus 2 times an 8x, a minus 2 times a negative x squared, and then here we can think of this as a negative 1. So I have a negative 1 times 64, negative 1 times negative 16, and a negative 1 times an x squared. And I'm going to solve all of those. So 16 times 8 is 128. We have a minus 16x here, and then a minus 16x here. So I have negative 2 times 8 is negative 16x. And then negative 2 times negative x squared is a plus 2x squared. And then we have a minus 64 plus 16 minus x squared. So I've solved each of those multiplications. So my brackets have all been expanded, and now I want to try and collect some like terms. So the first thing I have is a number that's by itself. It doesn't have an x beside it, so I'm going to try and combine all those together. I have a minus 64 and a plus 16. So I'm going to combine all that together. So 128 minus 64 plus 16 gets us to 80. Then I have a minus 16x, so just an x. I have another one here. I think that's all. So minus 16x minus 16x all together is going to get us to minus 32x. And then I have a plus 2x squared and a minus x squared. So that gets me plus x squared, so just 1x squared altogether. And so I've expanded my brackets, I've collected all of the like terms together, and so this is as simplified as I can make it. Okay, I want you to try question number 2. Pause the video, try it out, and then start it up again when you're ready. Okay, so the first thing I want to do is expand our inner bracket there. So I have 3ax minus ax, and then minus 5s plus 2ax. So my negative times a negative gets me a positive 2ax. And I'm going to do the same thing with the negative one outside of this bracket. Negative 1 times ax is negative ax. Negative 1 times negative 5s is plus 5s. And negative 1 times positive 2ax is negative 2ax. So now I've expanded all of my brackets, and I'm going to collect my like terms. So I have a 3ax, a minus ax, and a minus 2ax. They all have ax. So all together, I'm going to have 0 ax, right? I have a 3 minus 1 minus 2, I have 0. And then I have this plus 5s left on its own. And we don't want to write 0 ax, it's just 0. So I can simplify this even further to just 5s. Okay, try question number 3. Pause the video and then start it up again when you're ready. Okay, so this one has quite a few brackets. So the first thing we're going to do is find the innermost bracket, which is this here. And we're going to expand this subtraction out into both of the terms inside. So I'm going to copy everything else out. Make sure you're careful with keeping the brackets. Besides the brackets you've expanded, you're going to keep all of the other brackets because you don't want to miss one when it comes to expanding. So I get 3a squared b minus, and a curly bracket, a square bracket a, plus 2b. Okay, so now I'm going to expand what's inside of that bracket. So I have a minus 2a squared b plus a. So that minus 1 kind of changes the sign of the terms inside. And now I can expand this bracket here. There's nothing outside of it to multiply, so it means I can kind of just get rid of it. Because it's just multiplied, let's say, by a 1, so that doesn't really change anything. And now I can expand this bracket with the minus that's out front. And so I get 3a squared b minus a plus 2a squared b minus a minus 2b. So that -1 essentially changes the sign of everything inside. So now I've expanded all of my brackets and I can start combining like terms. So I have this 3a squared b. I have a 2a squared b, so they're both a squared b. I can combine them together, which gives me 5a squared b. Then I have a minus a and a minus a, and so I get minus 2a. And finally I'm left with this minus 2b left over by itself. So I can put that into my equation as well. Now I have nothing else that can be combined together, so I've simplified this expression. A final one for you to try. Pause the video and then start it up again when you're ready. Okay, so again, we're going to go to our innermost bracket, which is this bracket here, and it's got a minus out front. So I'm going to copy everything else out. Making sure to include all the brackets except the ones that I'm expanding. And so I have this minus that's going to apply to the 7, and it applies to the x. So now I can expand this bracket out with a minus 2 in front. So let's copy everything else out. Making sure to include all brackets except the one I'm expanding. And I'm going to apply that -2 to every term inside of the brackets. So -2 times 5 is minus 10. -2 times -7 is plus 14, and -2 times x is minus 2x. And let's just move that bracket up a little. Now I can expand this bracket with the minus out front, and I get 2 minus 3x plus 10 minus 14 plus 2x. And now I can start combining my terms. I've expanded all my brackets, so I'm going to start simplifying. I have a 2 that's on its own, a 10, and a minus 14. They all don't have any sort of letter next to them, so I can combine them together. So 2 plus 10 minus 14 is going to be -2. And then I have this minus 3x and this plus 2x. Gets me a minus x all together. Okay, so I want you to reflect on how you've done throughout this video and give yourself a ranking. Thumbs down if you're having trouble simplifying algebraic expressions and you need some help. Finger pointed if you need some more practice, and a thumbs up if you can simplify these algebraic expressions. You don't need any more help or practice.